Okay, now we're going to take a look at the trig subject. Trig is a difficult part of math for a lot of people, and it comes at the tail end of your Algebra 2 year. The problem is a lot of times schools squeeze your trig into just a very short period of time, and you really don't get as much time as you need to work on trig. So this video is for people that don't feel they had a good basis in trig. It's also for people that may have had trig, but it was a year or two ago and they would like a refresher on it. So what I'll be doing is going through it, and I'm going to start this first video. This is going to be a 2-video series on trig, but the first one, we're going to start with the basics of understanding the trig functions. Now, you hear the terms a lot: sine, cosine, and tangent. Sine, cosine, and tangent are the names of the basic 3 trig functions. Let's take a look at how they work. So when we start this, everything in trig is based off of a right triangle. Now, it works if it's not a right triangle, but it's still off of an assumed right triangle. And I'll go over that in a little more detail. But let's go ahead and take a look at the basics of a right triangle. If I look at this as my angle, this symbol is called theta. And if you want to see it big, theta looks more like this. All right? And so if you look at theta, theta is just a Greek word that tells us that's our angle. Sometimes you'll see it as ABC. Sometimes you'll see it named alpha, beta, gamma. Just doesn't matter. But all of that's roughly just telling us the same thing. So this is theta. We label our triangle relative to the angle that the ACT gives us. So I start with this, and across from this angle, opposite the angle, is labeled opposite. Then I have another angle. This is called adjacent. Adjacent means it's touching it, it's beside it, and that's this side. Then we have the hypotenuse. The hypotenuse is always across from the 90-degree angle. It is always the biggest side in a triangle is the hypotenuse. Now, to help us remember some of the basics of the trig functions, we have this little expression, sine or SOH CAH TOA. SOH CAH TOA. So you just remember that little thing, and the reason you remember it this way is because this expression, SOH, tells us that the sine function is equal to the opposite over the hypotenuse. Notice the O comes first, so it tells us the opposite is on top. We look at the CAH, C-A-H. That is the cosine function. The C for cosine, A for adjacent, H for hypotenuse. The tangent function. Tangent function, T is for tangent, O is for opposite, A is for adjacent. Now we're going to work with these functions just a little bit more. If I look at tangent, tangent is equal to opposite over adjacent. But tangent is also equal to sine divided by cosine. Not trying to confuse things too much, but it's designed so that the tangent of an angle is equal to the sine of the angle divided by the cosine of that same angle. So I can rewrite this and you'll see what happens. Tangent is equal to, well, sine is opposite over hypotenuse. So we would write opposite over hypotenuse divided by the cosine, which is adjacent over hypotenuse. Now you can see that my hypotenuses would cancel, and I'm back to this, opposite over adjacent. So this is the basics of the trig functions, and giving them a name. Now we're going to look at a couple of example problems. I'm going to work a couple on the board and talk through them as we go. Then you're going to work through some problems that are just like this. There's sort of a scattering of different problems to help you get a bigger picture of the sine, cosine, tangent functions as the ACT presents them. And after you work each one, you'll continue the video and I will have an explanation for it. And we'll go through it just like we've done with the other math subjects. Then we're going to go into the Trig 2 videos, and I will begin to work with some more advanced problems inside trig to help you understand everything from the unit circle perspective all the way to what you'll need for anything you might see on the ACT test. Now we'll go ahead and get started with this example 1. This is a typical problem that you might run into. This is what actually got me started in trig. is when I was in like the 6th or 7th grade, I started getting really interested in model rocketry. And I love building model rockets and watching them fly. And if you've ever done it, it's so cool to hit the button and watch the rocket just go and just shoot straight up into the air. You can't launch a rocket more than 1 or 2 times and it doesn't start crossing your mind. How high did the rocket go? Trig. So let's take a look. If I had the rocket, we would set the launch pad here. We would have somebody walk 500 feet away from the rocket. Then what we would do is use an angle. We had a special thing that we made that lets us watch the angle and see how high it goes based on the angle. And we would write down the angle, 43 degrees for instance. Then we would use a trig table to tell us how high the rocket went. So we fire the rocket goes up, and somebody's watching it go all the way up, and when it reaches the peak right here, before the parachute comes out, we mark that, and we know that angle. So now let's see, how high did our rocket go? Okay, I've got a few numbers here. We're going to look at this. Okay, the tangent, this is the tangent of a 43-degree angle. You can put it in a calculator, you can look it up in a table. And it's 0.9325. Now what this tells us is the ratio of my opposite to my adjacent is equal to 0.9325. Okay? So that's the way we look at this, is it's a ratio. So when I look at this, my opposite, this is the opposite on my triangle. This is my adjacent. My adjacent is 500 feet. So the tangent was 0.9325. So I would say 0.9325, which is tangent 43 degrees, is equal to opposite, which is my x, over my adjacent, which was the 500 feet, right here. Okay? So now all I have to do is multiply the 500 times the 0.9325, and I get 466 feet is equal to x. So this distance is 466 feet. That is how high my rocket went. So this is the kind of thing that you can use trig for very easily and solve some problems. Now we'll take a look at one more, and then we'll let you start working through some. Okay, now we've got a second problem set up. This is the example as to how it was. When I was a kid, we liked building tree houses because it was kind of fun to build a tree house. And then we wanted to have the little string phone or wire phone that we could talk to the house from. And so build a tree. You got a tree, and you build a tree house. You don't build the tree. The tree's already right. But you build the tree house, and you're up here, and you want to know, how long does this wire need to be to reach the house? And so you're like, well, I don't really know how long that is. Well, let me find out. So we would walk off the distance from the house to the foot of the tree, right here, right up underneath where our tree house was. That makes us a right triangle. That would be, for instance, in this case, 120 feet. So now we'd say, okay, it's 120 feet, and we want this one. So now let's go back and label our triangle. Go to the angle. My angle was a 15-degree measurement. You come over here. This is my opposite. This is hypotenuse. This is adjacent. So now we ask ourselves two questions in order to start this process. What did they give me? They gave me adjacent. What do they want? They don't want how tall the treehouse is off the ground. They want the length of the cable going back to the house. That's hypotenuse. So we use these two to tell us which function to use. All right, I have adjacent. I want hypotenuse. That tells me I'm using the cosine function. I will be using the cosine function. Now we set it up like we did before. Cosine of 15 degrees is equal to 0.966, and that is equal to the adjacent, which is 120, over x, which is my hypotenuse. Now I will multiply both sides by x, and I will have 0.966x equals 120. And when I divide by the 0.966, I get 124 feet for the distance. So I would need 124 feet of wire to go from the treehouse down to the house where I wanted to put it in. So hopefully this is giving you a little bit of an idea on how to start, and I think it'll just make more sense once you start working on real ACT problems, and I'll help walk you through that process. So let's get started on a few problems now. Okay, we're ready to start with this first problem. Now let's take a look at it. It says, for a right triangle ABC, shown below, which of the following expressions has a value that is equal to the cosine of A? Well, let's first find out what the cosine of A would be. Remember, we go to angle A. Across from angle A is our opposite. Our adjacent would be the 9-foot side, and our hypotenuse is the 15-foot side. So our cosine is going to be, the cosine would be the 9 over the hypotenuse. Adjacent over hypotenuse is 9 over 15. Now, what else would have the 9 over 15? So we go over here and we look at our answers. Sine of A. Well, if I look at sine of A, no, sine of A would be 12 over 15, so we know it's not A. The sine of B, now that's turning things around, and so I look at B and I would say this is my opposite and that is my hypotenuse, and that indeed would be the sine of B would equal 9 over 15, which is the same thing, so that makes the answer B for 29. Number 38. At a time when the sun's rays are striking the level ground at an angle of 37 degrees, a tree casts a shadow that is 41 feet long and as shown in the figure below. To the nearest foot, how many feet tall is the tree? Notice whenever the ACT gives you the sine, cosine, tangent values, you know you're going to be using SOHCAHTOA. You want to remember this, but for the first few, I'm going to write it out first so we can remember these are our three functions. So the very first thing we do is we go to the angle. Across from the angle is opposite. This is the hypotenuse. This is adjacent. Now we say, what did the ACT give us? The ACT gave us adjacent. What did they ask us for? Opposite. How tall is the tree? So the function that uses opposite and adjacent is the tangent function. So we go up here and grab tangent of 37 is 0.75. So we would say 0.75, which is tangent of 37, is equal to opposite, which is x, over 41. Okay, now we want to take a second and notice that to solve for x, we're going to multiply 41 times 0.75, and that'll get us 30.75 feet, which is closest to 31, making G the answer to 38. '39 gives us a little different way to look at what we've been doing. It says, in the right triangle shown below, which of the following expressions gives the correct value of C? Well, if you look at C, C is going to be the hypotenuse. Okay, how can we calculate this? Well, let's just start. If I did the cosine function, well, cosine function, I need adjacent, which I don't have. This is my opposite. This is my hypotenuse. I'm going to need a function that ties together my opposite and my hypotenuse. That is going to be a sine function. So that tells me A is out, C is out, D is out. So now I've got to set it up and say, okay, if I did the sine of 40 degrees, it is equal to 5 over C. Multiply both sides by C. C times sine of 40 equals 5. To solve for C, we divide both sides by the sine of 40. And that gives us the answer, B, for 39. .45, and it tells us that Tito wants to find the approximate height of a building, as shown below. When Tito is at a distance of 100 feet along level ground from the building, he estimates that if he must look up at a 50-degree angle to see the top of the building. If Tito is 6 feet tall, which of the following expressions gives the best estimate for the height in feet of the building? Okay, so which one's going to give that? First thing we do, we go to the angle the ACT gives us and label the triangle. This is opposite, this is adjacent, this is hypotenuse. Now we ask ourselves, what did they give us? They gave us adjacent. What do they want? Opposite. So if you remember your SOHCAHTOA, SOHCAHTOA, you should be recognizing by now that that is going to be the tangent function. So we would say the tangent of 50 degrees is equal to x for my opposite over 100. So x would then equal 100 tan 50, and that would make the correct answer E. Now here's where this plus 6 comes in. You'll notice every single answer has the plus 6. The reason is we're assuming he is 6 feet tall. So if he's looking straight across, he's looking at this part of the building. And you would add that 6 feet to it, whatever the height of the building is. So that's how the answer is E. But if you notice, all your answers had the plus 6, so you didn't have to pick up on that by itself. In 42, it says, in the figure below, LM is equal to MA. Okay, so this is equal to this. So you could say this is a 1 and this is a 1 if you wanted to. A, B, C, and D are on ME, and all of these angles are listed. Which one has the smallest sine? Well, now we have to remember our sine is equal to opposite over hypotenuse. Well, all of these sines are going to have the exact same opposite because the sine of this angle would be 1. The opposite of that would be 1. That would be 1. That would be 1. Every one of them is going to have 1 for their opposite. But their hypotenuses get longer and longer. So the one that's going to have the smallest one is the one with the smallest angle. Remember, sine of 0 is equal to 0. And then sine starts going up, 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 and then it maxes out at 90 degrees, which has a sine of 1. Then it comes back down. So the one that's the smallest angle will be the smallest sine, and that means that it would be LEM, making K the answer to 42. 32. The radius of the base of a right circular cone shown below is 5 inches, and the height of the cone is 7 inches. Solving which of the following equations gives the measure theta of the angle formed by the slant height of the cone and the radius. So we're wanting to know that angle. Okay? Well, notice what we have. Relative to this angle, this is my opposite, this is hypotenuse, this is adjacent. So they gave us opposite and adjacent. That's going to be the tangent function. So we're down to 2. These other 3 wouldn't be the answer. So now we have to write it out. Tangent of theta is equal to opposite 7 over 5. That makes the answer G for 32. (39) In an isosceles triangle with an angle measuring beta radians, where sine of beta is 12 over 13 and cosine is 5 over 13, what is the value of tangent of that? Well, remember when we talked about this before, tangent is equal to sine divided by cosine. So I can just do it just this way and say 12 over 13 divided by 5 over 13. The 13's cancel. And I just get 12 over 5, which makes the answer E. But let's look at it from our triangle standpoint. If I draw the triangle like this, remembering that I've got a 13 for the hypotenuse, a 12 for the opposite, and a 5 for the adjacent. And this is beta. Now, what I see is my sine is going to be 12 over 13. The cosine is 5 over 13. So the tangent would be opposite 12 over 5, and it works that way as well. Deanna peeks over the top of a fence post at a tree. The post is 4 feet high. If she is looking down at an angle of theta degrees, as shown below, what is the distance from the bottom of the post to the tree? Okay, so once again, we go to our angle the ACT gives us. And across from this is opposite. This, of course, would be the hypotenuse, and this is adjacent. And we ask ourselves, what did they give me? They gave me adjacent. What do they want? Opposite. So I know I've got to use the tangent function, and there's only one answer that's got tangent in it. That makes it pretty easy. (33) The triangle shown below has a hypotenuse with a length of 10 meters. The measure of angle A is 25 degrees and the measure of angle B is 65 degrees. Which of the following is the closest in length of AC? That is this distance here. Now the first thing you want to do is we've got both angles labeled. Well, we could always do both angles. If I knew this is 25, I could subtract it from 90 and get 65 for the other one. But what I do is I go by what did they give me the values for, and they gave me the values on the 25, so I'm going to use the 25 as my main angle. 25, across from the 25 is my opposite. This is adjacent. This is my hypotenuse. Now, what did they give me? They gave me hypotenuse. What do they ask for? They've asked for adjacent. So out of my SOHCAHTOA, SOHCAHTOA, I am using cosine because it's using adjacent and hypotenuse. So now what I'll do is set this up and say that the cosine of 25 is 0.9063. I'm just using their number and plugging it in. Is equal to adjacent, which is x, over 10. Now we just multiply both sides by 10, and I get 9.063 equals x, which is equal to 9.1, making E the answer to 33. "35, as shown in the figure below, with angles as marked, a pole casts a shadow that is 14 feet long. Which of the following is closest to the height of the pole in feet?" Now you notice they don't have sine, cosine, tangent values there. They want you to do this one using the 30, 60, 90 triangles. But we'll look at it as a trig one as well. But if I remember on the 30, 60, 90 triangle, what we have is if this is the 30, this is x, this is 2x, this is the square root of 3 times x. So if I look at it this way, that means across from the 30-degree angle, which would be here, this is the 30, across from that is x, 2 times that would be this is 28, and this would be the square root of 3 times 14. All right, and so that is what we're looking at. Now, if we take this and do it with trig, we would be saying we have been given our adjacent and we want opposite. That's the tangent function. Well, it just so happens, if you remember when we've gone through the tangent stuff on the unit circle, the tangent of 60 degrees is equal to the square root of 3, which is the same, the square root of 3 times the 14 is going to give me the length. And that is 24 degrees, or B, for 35. And that wraps up this intro set of trig problems. The next set you want to do is you want to go through Trig 2 video, which covers our unit circle, and you understand the functions and degrees and radians and everything a lot better after that intro video. And then we've got all of the advanced problems in Trig, which will help you start to understand those 45 to 60 problems a lot better.